the pot a little later. Okay, so there's a size difference here. It's the same material. It's the same semiconductor. The only thing that's been different is the size of the particle. 1 nanometer for the green ones, 4 nanometers for the ones that emit red. Why is that? Why is that? Well, you know other places around you where size makes a difference. For instance, when you're talking about acoustic waves. If I take a flute and I take a piccolo, they sound different. The flute sounds deeper than the piccolo. Why is that? It's because the sound wave that fits in a flute is longer than the sound wave that fits in the piccolo. The shorter the sound wave, the higher pitch you have. We also know that from organ pipes. You have the big organ pipes that can fit a big sound wave in them. They're deeper sound, lower pitch than the narrow, teeny organ pipes that are shriller. We also know that with strings. If I take a stringed instrument like this ukulele here, and I make the string shorter, the sound is a little higher pitched. Okay, where does that have to do with quantum dots? All this is the human scale. Well, it has to do with the electrons that are in quantum dots. When you think of electrons, you usually think of particles that are going through wires, powering your power tools, your chip, or whatever, little particles of charge. But if you take that little particle of charge, that electron, and you try to stuff it in a little box that's a nanobox in the size of a nanometer, it changes its properties. It becomes like a wave. It fills up that box like a wave fills up a flute or an organ pipe. This is quantum magic. This is this funny world where things don't behave the way that you expect them to behave. All right, so now I've got my boxes and I've got some electrons in there, but just like the strings on the ukulele don't sing by themselves, I have to do something to the flute to get it to emit a sound. I have to strike the particle somehow to get those electrons to behave like waves and for the energy to come out as light. Okay? So for the ukulele, I pluck it. That's how I create the sound. For the electrons, to get them to be waves, I strike them with light. I can strike them with a blue photon, or blue light, or UV light, and that creates those electrons. They become waves, and they start to emit the light. So now you know why they work. You know about the magic of quantum mechanics that makes them have different colors. And they're really little pieces of rock, so they're kind of stable. So it took us about 15 years to go through some really fundamental research to get to where we are in terms of understanding all this stuff. And about 10 years ago,